theory will be on the IT Theory LB grade 10 book. It's on the Google Drive, and then we'll start at, although it's term 1, unit 1, it's just going to be basically a recap and revision, and then obviously a few questions at the end. So ICT systems and IT, we all know that information and communication technology refers to basically all the technology that captures, transmit, process, display data and information electronically, and that can include all devices, applications and networking elements that allow people to connect in the digital world. So an ICT system refers to basically all the overall setup consisting of hardware, software, data and users, and these can include the people that supplies the data to make the decisions from the output supplied from the system's information, and also gives input. The hardware that basically is input devices, the storage, the processor, output devices, communication devices, etc. The procedures that actually determine what needs to be done and when and how. So that is basically when the data is actually passed between people or devices. Software, the computer programs which provide the step-by-step instructions to complete a task that the user wants to do, and then obviously data, which is raw material that is processed by the system to provide information. And then information or data can come in any kind of format, such as sound, images, video, normal typing, etc. The general model of a computer, so we all know the IPO system, which is basically the input, the processing and the output, which is the basic model of the computer. But here you can see that storage and process, I think that's actually supposed to be communication, but we will take process for now. But basically you input it, and once it's processed, it can either be stored or it can be communicated to over a network, or basically just transferred, and then at the end, if it's either stored, communicated, we can also output the information or data. Here's a quick description of what the IPO system is, but that's just basically what I said. Then we have activity 1, we'll get back to that. Hardware versus software, unit 1.2. So hardware is basically all the physical components of a computer we can see or touch. That includes anything like the keyboard, the hard drive, the processor, and so forth. Then software or application software basically refers to the programs on the computer that controls the hardware. So a bit more about hardware. So the physical components of the computer system. So like I said, something like keyboard, RAM, hard drive, CPU, etc. are part of hardware. So you get different categories of hardware. So you get like input devices, which will be the hardware that allows you to input data into the computer or to control the computer, interact with it. So like your mouse, etc. A storage device, so that is hardware that allows you to store data for a later use. So that includes something like the HDD or SSD, which is your hard disk drives, and your solid state drives. So we all know hard disk drives is the mechanical one, but all the one that uses magnetic disc platters that spin around, and you've got a motor that basically spins that platter, and then you have a read-write head which moves up and down and gather information in ones and zeros. Then we have the solid state drive, which is the much faster one, which basically works electronically and you don't have any moving parts in it. Obviously, difference between the two: HDD is a bit cheaper, but it is slower due to the mechanical use, and the solid state drive is normally a bit more expensive and way faster, and it does not have any moving parts. It's completely electronic. Then random access memory, or we call RAM. It is, some people would say it's a temporary form of storage. It is storage and such, but we mainly call it memory. And then all the data and instructions that a computer is currently busy with, that data and instructions get stored into the RAM. They also say here that RAM is volatile, and if you can remember what volatile means, is as soon as the computer loses power, everything inside the RAM is then erased from RAM. Then we have our processing devices, so that would be our CPU and the GPU. So the CPU is responsible for just processing general instructions. Every application makes use of the CPU to collect, decode and execute instructions as the application requires. Then the graphics processing unit is a bit more responsible for generating pictures on screen. So the CPU can also generate these, but the GPU is actually just mainly used for high intensity programs. If you look at gaming, where three-dimensional games normally rely heavily on a graphics card, and software like Blender and stuff, where you actually can create like 3D images and sculpt stuff, they are a bit more of a graphics, how can I say, intensive programs. So you need like a dedicated graphics card to get these images. Then our output devices. So output devices is any device that returns the computer's instructions to the user. So that can include monitors, printers, speakers, etc. Lastly, of the hardware is communication devices. So it's not like a mic. A mic would fall into an input device, but communication here means that your device actually communicates to another device or network. So that would be the capability of transmitting analog or digital signals over a wired or wireless connection. Okay, so that includes a modem, a network interface card that can either be wired or wireless. Okay, then our software. So that is, they categorize it as the non-physical components of a computer system. But software is basically all the programs and instructions the computer uses to complete an instructed task. Software is the program that is operated by the hardware, and then these include programs such as Microsoft applications, etc. Then they also say hardware and software are interdependent, which means without software the hardware can't be manipulated, and without hardware software can't be manipulated. Okay. So you need basically both to Okay, then the two main types of software that we get. Just scroll up here. The most important types is system software, which includes the operating system and application software. Okay, so system software is the specific type of software that manages the flow of data and information contained on the computer. The operating system is the most important type of system software. Okay, examples of system software or operating systems is Microsoft Windows, Linux, Mac OS, iOS, Android, etc. The operating system is designed to control and coordinate the tasks and functions of the computer hardware. Then we get application software, and application software is basically programs that is built for a specific purpose, like browsing the internet, typing a document, etc. Application software refers to any software that lets the user accomplish a function or create content. So that would be something like the Microsoft Word, where you can just type out an assignment or a document and then just save it. Then what they also like to ask is, what is an application suite? So that is basically when a group of programs are packaged together. Like if you look at Microsoft Office, you've got the Word, Excel, Access, all that programs that is basically comes together. Okay, then types of software you get, or application software, is shareware, freeware, open source and proprietary software. So just write this. So shareware is basically when copyright software is distributed for free, but it contains a trial period. So normally if it's a game, you only get like the 2 first levels, or if it's a program, you only have 5 days free, and then you have to buy the program thereafter. So it's basically a time trial type of function you have. Freeware is software available to you free of charge, but the company or the people that distribute the software keeps the rights to the software. Then we have open source software, or people normally call that free open source software. Is software that the source code is basically available to anyone and the public, and you are allowed to actually change the source code and to customize the program. Then proprietary software, the software is developed using that source code. I mentioned open source software. So that source code, where open source is free and everyone can see it, proprietary, the software source code is hidden and you do not get the access to the source code. So here the proprietary software is basically the owners or the company keep it safe, because I mean that's how you can actually make a copy of the program or steal ideas. So they like to keep that safe, and then you basically just buy a license to use the program. Okay, so here's examples and disadvantages, advantages of each one. You can just scan through quickly, and then we carry on. So that's part of the activity. Okay, types of computers. Okay, so the types of computers or roughly depend on the purpose that the computer has to do. We've got many examples like desktop computers, laptops, tablets, smartphones, servers, and this one, which we normally don't really focus on, but embedded devices. Okay, on the next page we can see all the different users. So computing devices such as laptops that are basically used for anything. It's similar to a desktop computer, but yeah, the mobility is mainly what separates a desktop and laptop the most. And obviously, processing power, but I mean, you do get good laptops that has the processing power of desktops, but if you look at price range, it will cost so much more than the same level of desktop you have. So yeah, the processing power of laptops are also medium to high processing power. Like I said, full mobility. Then we have desktops. Desktops are exactly the same for as a laptop, but the desktop is not mobile. Also processing power, medium to high processing. Then we have smartphones, which has low to medium processing power, but the mobility is excellent here. Um, Smartphones are better than desktops at tasks that require a very mobile device, like taking photos, setting the alarms, navigating roads, etc., sending, receiving short messages on the go. Then we get tablets. So tablets, it's basically a smartphone on steroids, as I always like to say. But a tablet has a keyboard on screen. Um, you can have applications same as a smartphone, and some desktop applications actually can work on types of tablets. So then you have like a mini laptop. Again, excellent mobility, but you only have medium processing power because of the size. Then we have servers. So servers are designed for managing networks, providing access to specific files and hosting websites, as well as processing huge amounts of data. The processing power of servers are very very high, and they have no mobility at all. Then we get embedded computers. Embedded computers are basically devices designed for a fixed purpose. So that would be basically something like a temperature air conditioner system, a refrigerator, or like a GPS basically. They have very low processing power, and the mobility basically varies depending on the device. If you like have a fridge, you're not gonna keep on moving the fridge every 5 seconds, so the mobility there would be very low. But if you look at something like a navigation system or a sat nav, then I mean it moves with you in the car, but you can't physically take out the navigation, except if it's a GPS you can just clip on, so then you can carry it around with you everywhere you go. And then is part of the activity. And then lastly, advantages and disadvantages of computers. So advantages of computers is it provides access to a lot of information, complete tasks that might be impossible for humans to complete. It saves time. It's great at repeating repetitive tasks. It allows for greater productivity, allows for excellent entertainment and communication and connections. Disadvantages of computers is social risks. So some people can become antisocial just keeping on social media, and there can be some things like stress and jealousy, addiction that can be risks of computers. Health risks include straining on the eyes, back pain, carpal tunnel syndrome, repetitive strain injury, but these health risks can be reduced by using um, good ergonomic practices. Then we have got security risks. So computers can cause great security risks. Um, when malware infects your computer. So here an attacker can actually gain access to your system and sometimes to bank details and all your personal information. Then we've got high cost. So computers normally are quite a bit expensive, and an average person in South Africa might find it a bit too expensive to use. Then 5, we've got distractions. So computers normally causes great distractions. If you think of trying to study for an exam, you see your phone or your laptop just sitting there calling your name. You know what I mean. Then lastly, environmental impact. So computers normally use a lot of electricity, and in most cases electricity generation is quite harmful to the environment, because of carbon emissions and so forth. Okay, so that is all for this lesson. So the activity that needs to be done, I'll post this, but it is basically from the top all the way down, from activity 1.1